Susana Martinez-Conde, along with her partner and collaborator Stephen Macknick, are among the world's preeminent experts on illusions and perception and what they tell us about how the brain works.
Now what? To give a different example, Adelson's checkerboard illusion is so striking because you see some of the checks as dark and others as bright, but you realize that it is exactly the same shade of gray.
Don't believe it? Look at the squares labeled A and B. A looks darker, right? Wrong. That's the illusion. That's because your brain is adjusting for the shadow.
What's happening is that your brain is considering the light source and basically subtracting that light source from your resulting perception.
What you need to understand is that we really can't see most of the world around us. We're effectively blind to 99.9% of the world around us at any given time. If you hold out your thumb at arm's length, and you straighten your elbow and you look at your thumbnail is about 1 degree of visual angle here. And it turns out that that's the only place we can actually see with 20/20 vision.
Wow.
And everywhere else we're legally blind.
It might sound hard to believe, but human vision is really like this. You actually only see detail in about 1% of your visual field. That's because only a tiny portion of the world can be processed in detail by the retina. It feels like I'm seeing the whole world in 20/20 vision.
And it's almost all completely made up in your brain based on assumptions and models of how the world works and just a tiny bit of high-quality visual information.
Here's how your brain really sees the world. It's easy to think it's like this. You open your eyes and the whole world pours in, but really it's like this. Your eyes sample tiny pieces of the world and the brain fills in the rest, constantly, all the time. Consider this. Your optic nerve is what connects your eye to your brain, and its location near the center of your retina effectively creates a blind spot near the center of your visual field. And yet, you don't experience the blind spot. Why? The brain samples the area near the blind spot and fills in the gap with its best guess.